Hi everyone, a very good evening to all of you. Today I'm a little more happy than a normal day. I don't know why. Sometimes we feel like that. It's okay. So this is the part 1 video of physical chemistry, important topics and sources. In last video, organic chemistry, I forgot to discuss about the important topics of organic spectroscopy, right? So regarding organic spectroscopy, inorganic spectroscopy and physical spectroscopy, I will discuss those all three with inorganic video. Okay, so in this video we are going to discuss, this is the part 1 video of physical chemistry. In this video we are going to see the important topics of chemical kinetics, surface chemistry, polymers and solid state. Okay, so why I'm not doing entire video at once? Cause it is the analysis of papers is not that easy. Really, I'm telling you, analysis of question papers, analyzing every question paper, analyzing whole syllabus of physical chemistry, organic and inorganic is not that easy. So it takes a lot of efforts and a lot of time. So that's the reason why I'm making this video, due to lack of time, right? So that's why this is the part 1. So physical chemistry is of 2 parts. Part 2 video will come. Okay, so that's all. We will see what are the important topics. So first one is chemical kinetics. In this chemical kinetics, so I can't write everything on board. Okay, so here order of reactions are very important. So these are the important topics, no doubt. So these are only the important topics in chemical kinetics. See, whenever it comes to physical chemistry, you just focus on formulas more. Okay, yes, I agree, paper is getting conceptualized, but whenever you are preparing all three, physical chemistry, inorganic chemistry, organic chemistry, you don't need to be afraid. Okay, so you have so much of syllabus, you are covering so much of syllabus, so that you have so much of choice. Okay, even if you are not able to attempt one particular question, one chapter, for suppose one complicated question will come in chemical kinetics. Okay, if you cannot do that complicated question, no problem, because you are covering almost maximum syllabus. That's why I am saying always cover as maximum as possible. So whenever you cover the syllabus as maximum as possible, then you will have more number of choices in examination hall, right? Even if you will not able to do a particular question regarding particular chapter, you don't need to worry, you can attempt other question in any other chapter, right? So that's the main suggestion. Okay, so first in chemical kinetics, order of reactions are very important. First order, second order, third order reactions, nth order reaction. Okay, these are very important. So in this order of reactions, what you have to see, what are the units? Okay, you have to see the units of order of reaction. 2 marks definitely. So one thing is clear, 1, 2, 3, 4, 5, 6. If you cover these 6 topics in this chemical kinetics, definitely you will get at least 10 marks, at least. Okay, so definitely on order of reactions, first, second, third order and the nth order reaction, their half-lives, their units, their graphs. Okay, their graphs, if you concentrate on those things, okay, definitely you will get marks. You will get 1 4 mark, you will get 1 2 marks. Okay, so that is the first thing. Second thing, reversible, parallel and series reactions. What you have to do, simple, you don't need to focus on theory. For reversible, parallel and series reactions, just to focus on formulas and previous year questions. Just all physical chemistry, total all chapters of physical chemistry, you have to focus on formulas only. Most probably just focus on formulas and do previous year questions more. Okay, that is more than enough. And now for reversible, parallel and series reactions also, you have to remember the formulas, they are more than enough. Second thing, very important thing, half-life. Okay, so one formula, one relation is there, 2 half-lives will be given to you, and the relation between concentration and half-life. If you ask me, you cannot see any question paper without this question, the relation between initial concentration and half-life. T half 1 by T half 2 equal to A02 by A01 whole power n minus 1. Very important formula, don't leave that. And remember the general formula, Kt equal to 1 by n minus 1 into 1 by 80 power n minus 1 minus 1 by a0 power n minus 1. This is the general equation for the order of reactions. Okay, so these are very important. So focus on 0 order, first order, second order, third order, nth order reactions, their half-lives, their graphs, and also the formula of initial concentration, the relation between the initial concentration and half-life. Okay, they are very important. And when it comes to series reactions, parallel series reactions, reversible reactions, just focus on formulas and do the questions of previous years, more than enough. So next one is collision theory, activated complex theory, Lindemann theory. In this also, in collision theory also, you don't need to focus much on theory. Okay, so theoretical based question, rarely you will find the theoretical based question on this. Okay, remember the formula and do the questions on collision theory. Okay, you have to have a basic knowledge on collision theory. Okay, you have to have a basic knowledge on collision theory, activated complex theory and Lindemann theory, but you don't need to go into depth. Okay, so on collision theory also you have to remember the formula, do previous year questions. Okay, so next one is transition state theory or activated complex theory. Definitely you can get one question on this. Okay, every time, especially this activated complex theory is most important for GATE. Okay, so next, Lindemann theory. Already question came in the last GATE examination, right? I discussed also in our channel. So Lindemann theory is also important. Lindemann theory of unimolecular reactions, very important. When it comes to CSIR NET, we can't expect theoretical based question. Okay, in last GATE, yes, they asked theoretical based question, but we can't expect that. So remember the formulas also. Okay, so remember the formulas of Lindemann theory. Okay, so next one, kinetics of photophysical process. So in this kinetics of photophysical process, what you have to do? Jablonski diagram is very important. Jablonski diagram is very important. Remember that Jablonski diagram. Quantum efficiency phi equal to 12 n by 100 lambda e. That formula is very important. Direct question will come on that. Temperature jump experiment, gamma equal to 1 by k1 plus k minus 1. That formula is important. Only you have to remember the formulas, and moreover you have to remember Van 't Hoff equation. Okay, so remember Van 't Hoff equation, d ln k by dt equal to E by RT square. That is also important. And you have to remember quantum efficiency of phosphorescence, quantum efficiency of fluorescence. Okay, relaxation time of phosphorescence, relaxation time of fluorescence, the relation between half-life and rate constant. T half is inversely proportional to the rate constant. Just you have to remember the formulas. Okay, so when it comes to Arrhenius equation, definitely you will get one question from Arrhenius equation. Don't leave that. Remember the formulas of Arrhenius equation. You have only one formula, two formulas are there on Arrhenius equation. K equal to AE power minus EA by RT and log K2 by K1 equal to EA by 2.303 R into 1 by T1 minus 1 by T2. These two formulas are very important, and the relation. Okay, you have to find out the overall activation energy. Okay, that formula is also very important on Arrhenius equation. So without Arrhenius equation question, you cannot expect the question paper. Okay, at least for the 2 marks, Arrhenius question will come. Okay, so next, kinetics of photophysical process over, and enzyme catalysis. For enzyme catalysis also, so you have to know a basic idea on enzyme catalysis, what is enzyme catalysis and everything, and Michaelis-Menten plot, very important, Line-Weaver-Burk plot, very important, and Eddy-Hofstee plot, very important. So in the Line-Weaver-Burk plot and Eddy-Hofstee plot, you have to remember the main equation and also graphs. Okay, so how you have to find out the graph? You have to know to draw the graph. Okay, what is the slope, what is the intercept, you have to know those things. And in Michaelis-Menten equation also, you have to focus on turnover number or turnover frequency. That formula is very important. Catalytic efficiency K2 by Km. Okay, and slope and intercept of the graphs, and one more important formula, Km equal to K minus 1 plus K2 by K1. Okay, that is also very important formula. So just thoroughly revise all the basic things of this topics and revise the formulas, do the questions. Okay, that is more than enough. Next, surface chemistry. When it comes to surface chemistry, properties of physical and chemical adsorption. So read basic terms, adsorption, absorption and everything. And very important, what are the properties? Reversible nature. Okay, effect of temperature, effect of pressure. So how effect of pressure in physical adsorption, in chemical adsorption. Okay, you have to compare both. comparison of physical and chemical adsorption. They are very, very important properties of physical and chemical adsorption. There is one chart. If you find out the if you see any book, any standard book, you can find the chart. Okay, that chart is very, very important. So next one is formula of relaxation time. Gamma equal to gamma naught into e power EA by RT, right? So in the adsorption, there is a formula gamma equal to gamma naught into e power EA by RT. That formula is very, very important. Just remember that formula and do the questions. Next, Langmuir adsorption isotherm along with graphs. Okay, here also in Langmuir adsorption isotherm you have two formulas, mainly two formulas, that is theta equal to Kp by 1 plus Kp1 formula, Kp equal to theta by 1 minus theta 1 formula. You have to remember that, right? You can expect the questions on both the formulas. Okay, definitely. And next one is graphs of Langmuir adsorption system, very, very important. The applications of Langmuir. In these applications we have two graphs, 1 by VAD versus 1 by P. One graph is there, P by VAD versus P by P by VAD versus P. One graph is there. Definitely question will come on gate for sure. In gate definitely you can expect the questions on these two graphs, and also in CSIR NET also these two graphs are very, very important. So next one is Freundlich theory of adsorption. Here also graph is there. You have to remember. When it comes to beta isotherm, actually beta isotherm is not that important, but recently, okay, so generally in these days in question paper this examiner is asking about the beta isotherm. So only two things you have to remember. Beta isotherm indicates multi-layer adsorption. Okay, so one thing is it is multi-layer adsorption. Second thing, for the beta isotherm one formula is there, only one important formula is there. According to that formula you have to draw the graph also. Just remember that formula. Okay, so that is more than enough for beta isotherm. So next one is polymers, right? So for polymers, number average molar mass, weight average molar mass, viscosity average molar mass, Z average molar mass. So formulas are very, very important, and you have to know the relation between them. You have to know the relation between them, which average molar mass is very high, which average molar mass is very low, and also there is a graph, okay, to indicate the relation between the molar masses. You have to know that graph also. Okay, you have to know that graph. And osmometry formula is there, pi equal to CRT, right? And that formula is also very, very important. Do the questions on that. Mark-Havnik equation, and very, very, very important Mark-Havnik equation. Relation of, again, yeah, relation of average molar masses, and contour length formula is important. Root mean square radius, radius of gyration, average radius. These four formulas are also very, very, very important. Contour length, root mean square radius, radius of gyration, and average radius. Degree of polymerization, you have 3 to 4 formulas on degree of polymerization. Definitely you can expect one question on degree of polymerization. Okay, so next, link average 1 by 1 minus P, and you can expect question K equal to 1 by 1 minus P. You can expect question on this link average also, right?